Welcome back, everyone. Moving on to the next video. What we got to do is take both of these equations here and solve for x. So notice these are exponential equations because they have exponential terms within them. And when you get something like this, what you ultimately want to try to do is get everything in terms of the same base. So you can end up with something like a to the power of x equals a to the power of y, right? Where we have the same base, and then these here are going to be expressions. So then we could drop the bases, and then we could just solve that equation, right? We want to get rid of the exponential expression. So if we can get everything in terms of the same base, well, if the same base to the power of x is equal to the same base to the power of y, well, that means that the exponents then have to be the same. And then this remaining equation that we're going to get is going to be a lot more simple to solve. So let me show you how to apply that. So here, notice that we have a base of 3, and a base of 9. And notice that the base of 9 we could change to a base of 3. So what we can do is take this 9 and change it to 3 to the power of 2. That's going to be to the power of x, and then that's still going to be all to the power of 2. So all I did was I took this 9 here, put it in brackets, changed it to 3 to the power of 2. That's still going to be to the power of x, and then that whole thing is still to the power of 2. And so what we can do now is, actually no equal sign there. Equal sign is on the right side of this expression, so we'll have equals 3 to the power of 10. Now, what can we do here? Notice that we can multiply these exponents, right? If you remember your exponential rules, a to the power of x to the power of y equals a to the power of x times y. And if we have another term on the outside, we just multiply that term. So 2 times x times 2 would give us 4x, like that. And so now we're getting a lot closer, but what we want to do is have one exponential expression on each side of the equal sign. So notice the 3 to the power of 10 times the 3 to the power of 4x. We can rewrite that as 3 to the power of 10 plus 4x. Because they have the same base, right? The exponential rule for that is this. We add the exponents, right? Notice how it's different from that. And now, notice what happens. Same base, one exponential term on each side, so we could just drop the bases, right? If 3 to the power of 6x equals 3 to the power of 10 plus 4x, well, that means that this and this have to equal. And now this is just a simple linear equation. So bring the 4x over, 6x minus 4x would give us 2x, 10 divided by 2, x would be 5, like that. Now you can also check your answer. You could take this and plug it in here, plug it into the left side, plug it into the right side. It's going to be a pretty big number, 3 to the power of 30. But get that value, then plug in x equals 5 here, and both sides should be the same. So that's how you could check your answer, right? So the answer for number 1 is x is equal to 5. Now what about number 2? There's a lot more going on here. We got 1 over 8 times 2 to the power of 3x plus 2, all to the power of 3, and that's equal to 32 over 4 to the power of x plus 2. Now, before getting into any sort of algebra or simplifying, notice that we can make everything here in terms of a base 2. The 8 we can rewrite as 2 to the power of 3. This already has a base 2, so let's just keep it. Notice the 32 we can rewrite that as 2 to the power of 5. And then notice the 4 we can rewrite as 2 to the power of 2. And that's going to be to the power of x plus 2. Right? This 4 I wrote as 2 to the power 2, and then we still have that outside exponent. And now notice everything is in terms of the same base. There's still a lot of algebra left here to simplify, but this looks a lot better than this because we had all these different numbers to work with. Now we have everything in terms of the same base, so we just have to get to that same point where we're going to have 2 to the power of something equals 2 to the power of something, and then we could drop those bases. So the question is, how are we going to do that? Well, if we continue this I'm going to keep, and then I'm going to take this 2 to the power 3 and put it under this. Right? This is like over 1, so we could combine these into one fraction. Sorry, I shouldn't put an equal sign there. That's not proper format. There's only one equal sign. That should be going down the page. So continuing this here, we'll have 2 to the power of 3x plus 2. That's going to be to the power of 3 all over 2 to the power of 3, like that. And then over here, we'll have 2 to the power of 5. Now, notice this here, what we can do is we can multiply these two exponents, but you got to multiply this whole thing. So it would be 2 to the power of 2 times x plus 2. What is that? 2x plus 4. Okay, you got to be careful with something like this. We're not just, if I take this and rewrite it here, we're not just multiplying the x by the 2. Okay, this whole thing is an exponent. So you wouldn't write this as 2 to the power of 2x plus 2. That would be incorrect. You got to take the 2 multiplied by this whole thing. Okay, if we bring back that rule, this and this whole bracket represents like this y, and then this 2 is like this x. Okay, so we're multiplying that whole thing. That's how we get that 2x plus 4. So just be careful with things like that. That's going to happen over here as well. So from here, the next line, what we can do is apply the same thing up here, but that would be 2 to the power of, what, 9x plus 6? Right? 3 times 3x plus 2 would give us 9x plus 6 all over, put the equal sign again, just a bad habit, equals 2 to the power of 5 all over 2 to the power of 2x plus 4. And now notice we have exponential expressions with the same base that are dividing. And so we know that if we have something like that, the exponents subtract. So what would happen here is we'd have 2 to the power of 9x plus 6 minus 3. Combine them into 1, same thing here. 2 to the power of 5, we're subtracting that whole exponent, so that's in brackets. Right, so the brackets in this particular equation are pretty key here. You got to be careful with these brackets when you're multiplying, and then also in this step, it's this exponent minus that whole exponent, so that whole thing goes in brackets right there. So this would end up being 2 to the power of 9x plus 3. Right, these are like terms that simplify to 3, and then over here we'll have 2 to the power of 5 minus 2x minus 4 if we distribute that negative inside the bracket. And so we would end up having 2 to the power of 9x plus 3 equals 2 to the power of 1 minus 2x. Like that. 5 minus 4 is just positive 1. Notice now we can drop the bases. We could have actually dropped the bases at this point too, and then just solved. We would get the same answer, but I decided to simplify the exponents at this point and then drop the bases. So we would end up with 9x plus 3 equals 1 minus 2x. So this would end up being negative 2, 11x. Right, when we bring the 3 over, when we bring the negative 2x over, so x would end up being negative 2 over 11. Right, so that ends up being the final answer for number 2. And again, if you have the time, you could check your work, you could take this, plug it into both sides. Both sides should be equal.